Hi everyone, these are 2.4 notes where we're focusing on the end behavior and the y-intercepts. So first of all, we should have done this exploration here where you discovered that anytime we have an even degree or an even power, even means same. They're going to be going in the same direction. So these are both going down, both going up, both going down, both going up. And how do we know if they're going up or down is if it's a positive in front or a negative. So an even power, 2, 4, 6, 8, who do we appreciate? Those go in the same direction. Positive, they both go up. Negative, they both go down. So you should have known that for x squared. Yeah, x squared, the parabolas. And what you're learning is that, oh, it also works for the x to the power of 4. Okay, so evens go in the same. An odd power, an odd exponent, an odd degree, they go in different directions. And how do you know which way they go? It's the same as a line. Y equals x, a positive slope, will be increasing like this in the down to up direction. And here it's decreasing if it's a negative odd. So let's turn to the back. And we're going to do the back of the notes. So we usually don't draw those arrows. Those are just the introduction. Instead, we're going to use these phrases. And it's a little annoying at first, but it's not that bad. So as x goes to, we're going to fill these in. Okay? If x is going to positive infinity, then what direction is it moving, left or right? If x is going to positive infinity, that means it's moving right. And f of x is y. So if y is going to positive infinity, then that means it's moving. I was going to write the word up, but my u became a y. So we're going to write up. Here we go. Up. So here x is moving to the right, and f of x was going to negative infinity. F of x means y. So y, that means y going down. Okay. And then this is moving to the left, x is going to the left, and y is moving up. And as x is approaching, sorry, here's how we officially say it. As x is approaching, use the word approaching for this arrow, A-P-P-R-O-A-C-H, approaching, or approaches. As x approaches negative infinity, f of x approaches negative infinity, which means it's moving down. All right, in the 2.3 check for understanding, we talked about how many times was a factor a 0? How many times? Did you remember that? How many times? You said 3 times, 2 times. Well, that is called multiplicity. How many times a particular number is a 0 for a given polynomial? For example, in the polynomial, do you see this? Do you see that 4 up there? So this is a factor 4 times, which means 3. The 0, 3 has a multiplicity of 4. And how many times does the 5 appear? Only once. So that's a multiplicity of 1. And 8 will appear twice. Although this polynomial has only 3 zeros, we say that it actually has 7 zeros, counting multiplicity. And so that would be a power to the 7. Okay. You ready? Here we go. How many zeros do you see here? I see 1, 2, 3. And 3 means f of x is a cubic. The left end behavior, as x goes to negative infinity, that is because it says left end behavior. So as you go on the function to the left, where is the arrow pointing? Up or down? It's pointing down. So as x goes to the left, f of x is approaching negative infinity. Let's talk about the right end behavior. Look at the right side. As x approaches positive infinity, where's the y value going? F of x is approaching, it's going in what direction? Up. So that's also positive infinity. Okay, each of these zeros has a multiplicity of 1 because it just crosses through the x-axis. Do you see how it just crosses through? So the zeros are x equals -2, x equals -1, and x equals 1, and they each appear only one time. And so this is our function, f of x. Okay. Now, let me, I'm trying to figure out where to write this. Okay, this is kind of cool. If something has a multiplicity of 1, it will just cross through the x-axis like a line, like a linear equation. So here's a mini graph. Do you see that? A multiplicity of 1 will just cross through. Okay? But if you have a multiplicity of 2, then it's going to bounce. What? It will bounce. So watch. A multiplicity of 2 will look like this. Well, because this is going to look like a line, a linear, x equals 1. But this is going to look like an x squared. So a multiplicity of 2 will come down and then bounce back up. And do you see that resembles an x squared? And then a multiplicity equal to 3, it's going to look like a cubic. But watch, it's going to do something funny. It's going to, it's going to lay down. Lay down. So it's going to come up, and it's going to kind of lay down for a split second and then come back up. It's actually called a zero tangent line. So multiplicity of 1, that's how I knew all of these were 1, because they cross, cross, cross. So will it cross? Does it bounce? Or does it lay down and then go back up? So it kind of lays down, but then it still crosses. Do you see how this is different than this? All right. Okay, so let's look at G. Now, it's almost like we need to start. We're going to skip this. We don't know this yet. This is a question mark. Okay, let's talk about the left-hand behavior. So as x approaches negative infinity, that means left. Where is the y value going? A circle. I see the arrow pointing up, so it's going towards positive infinity. And the right-hand behavior is also going up. So as x approaches positive infinity, that means to the right, f of x will approach positive infinity. Okay, so where does this first sentence come from? It comes from the word left. And then this comes from the arrow pointing up. This first sentence comes from the word right. And then this second part comes from the word up. So we know it's even. Yeah, do we know it's a 2, 4, 6, 8? Because they're both going in the same direction. And we know it's positive. You agree? Okay, so let's talk about the zeros. So the zeros, we're going to say that's 2.5, and this 0 is 2. Do you see any other zeros? So if we have a 0 equal to negative 2.5, now what do you think? Do you think this is crossing, bouncing, or laying down? I think it's just a cross. So we're going to say this has a multiplicity of 1. What would this be in fraction? 5 halves? How come I made it positive, right? Because oh no, I froze. I'm sorry, hold on. I wonder when I froze. Okay, I don't know when I froze, but the lights went off and I froze. So opposite sign, opposite sign, opposite sign. So this has a multiplicity of 1, a little power of 1 there. Okay, let's look at this 0. X equals 2. Dun, 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 dun. Finally getting exciting. You tell me, does it cross? Does it bounce? Or does it kind of lay down and then keep going? See how it kind of lays down and then keeps going? So this has a multiplicity of 3 because it actually looks like an x cubed, and this looks like an x squared, and this looks like an x. So it actually looks like an x cubed locally, looking right at the 2. So watch what we're going to do here. This has a multiplicity of 3. Cool? we're going to do one more thing. You see that 5 halves? We usually don't have that there. So we're going to say G is it positive or negative? Are these both going up or down? They're both going up. So G is a positive 2x plus 5 times x minus 2 to the third power. So what do these powers add up to? This is 1 and this is 3. So what's 1 plus 3? 4. So this is a positive, what are the 4s called? I forgot. Just kidding. I'm just teaching you how to go look. So if you have a degree of 4, it's going to be called a quartic. I don't like why are those mixed up? Anyways. Okay, so G is a quartic, Q-U-A-R-T-I-C, and it's actually a positive quartic, a positive x to the 4th. Could we multiply all that out? Yes. Do we want to? You know, it's up to you, but I'm not going to do it today. I want to just keep going and end these notes. Let's look at H. Holy moly, look at all those zeros. Okay, now you should be ready. This is a multiplicity of, is it 1, 2, or 3? Cross, bounce, lay down. Cross, 1. Does this one cross or lay down? Cross. Does this one cross, bounce, or lay down? Bounces. And then does this one cross, bounce, or lay down? Crosses. So it looks like we have 4 zeros, but since this one bounces, it has a multiplicity of 2. So we're going to say it has 1, 2, 3, 4, 5 zeros. And so what's it called with the 5 zeros? It's called a, you could say quintic or quintic, because we know it's the city of La Quinta and not the city of La Quinta, right? I know that. Okay, left. As x approaches negative infinity. Do you see how that's the same every time you say left? Where is the arrow pointing? Is it pointing up or down? This is the blank you're filling in. Right. As x approaches positive infinity, is the arrow pointing up or down? All right, so as we go to the left, up or down? Down. As we go to the right, up or down? Up. So we say positive infinity. Okay, so it's a positive quintic, which means the end behavior looks like that, which it does. All right, what are the zeros with the multiplicities? So how many times does x to the 4? X to the 4 is going to be a multiplicity of 1. So we're going to have a power of 1. X equals negative 2 is also a multiplicity of 1. How do we know? Crossing, crossing. What about the 0 at 2? Is it crossing or bouncing? It's bouncing. So we're going to say x minus 2 squared. Because there's 2 of them because it bounces. It goes boop, boop. And that 0 at 5, x equals 5. So our factor is x minus 5. Cool. Do these powers add up to 5? 1, 2, 3, 4, 5. Yes. And what is this called? This is called h of x equals that. That's the end of our notes. We're going to have lots of practice coming up. Thank you for watching. A student sent me a joke, so I thought I'd show it to you guys. Here's a joke to end the notes. Six was scared of 7 because 7 ate 9, but why did 7 eat 9? Because you're supposed to eat 3 squared meals a day. Do you get it? 3 squared. Awesome. Thanks for watching.